Hey chemists, how you going? Just want to talk you through an example stoichiometric practice problem with a titration. So for this one, we're calculating the concentration of hydrochloric acid. If 20.0 ml of it is neutralized by 23.7 milliliters of 0.600 mole per liter ammonium bicarbonate. So the first thing you want to do is make sure that you have a balanced chemical equation. So in this case, we have hydrochloric acid, HCl, plus ammonium bicarbonate. Now the ammonium ion is NH4 plus, and bicarbonate is HCO3 minus. So that's going to combine to NH4 HCO3. And that is neutralized, so we have an acid-base reaction. So essentially we have the ammonium salt being formed. So the ammonium ion is going to combine with the chloride ion to make NH4 Cl, and then we'll have water, and because it's a carbonate base, we are also going to have carbon dioxide. Now I'm going to draw that, and then I'm probably going to move over it. It's not going to be relevant, so that's okay. So the next thing you want to do is to construct a table underneath where we can write down our important information. Okay, so with my table of values, I'm going to get the important bits of information down from the question. So hydrochloric acid has a volume of 20.0 ml. So for HCl, under V for volume, I'm going to put 20.0 ml, but I'm going to convert it to litres straight away because the base unit for volume is litres. So that's going to be 0.0200 litres. You divide by 1,000. Neutralized by, and I'll change colour here, go purple, 23.7 ml. So that's your ammonium bicarbonate. So here's the ammonium bicarbonate. 23.7 ml is going to be 0.0237 ml. And the concentration is 0.600 mole per liter. So ammonium bicarbonate concentration is going to be 0.600. And the question's asking what's the concentration of hydrochloric acid. So this is the part that we want to find out. So the first step is you want to calculate your concentration of your known substance. And our known substance is the ammonium bicarbonate because we have two values, and we can calculate the number of moles, which is the number of particles that's reacting for this reaction. So our first step is going to be number of moles of NH4 HCO3. And the formula is concentration times by volume. So we just multiply the two values together. So 0.600 times 0.0237. Now we could put that in our calculator to get an answer, but I'm just going to leave it for now, and we'll do our calculation in one go at the end. Our next step is to calculate so we've gone and calculated our number of moles. Once we figure out what that is. Our next step is to convert the number of moles of this known substance to our unknown substance, which is HCl. So in order to calculate the number of moles of hydrochloric acid, that's going to be the number of moles of ammonium carbonate multiplied by the mole ratio. Now the mole ratio is multiplying the coefficients, and it's the coefficient of the unknown substance, which in this case is our HCl. Actually, maybe I should do that in blue. Divided by the concentration, the coefficient of the known substance. Now in this case, the coefficients of both our reactants are 1. So this ratio doesn't matter. It's going to be 1 divided by 1, so the answer is going to be the same thing. So essentially, the number of moles of HCl is just going to be the same as previous. But if you had coefficients, then you'd need to multiply by that ratio. So I'm just going to put equals, and I'll have the same answer as previous. Just put that there. Cool. So our next step, or our final step, is to go from our number of moles of our known substance and convert to the desired quantity, in this case concentration. So I want the concentration of HCl. And in order to do that, I'm going to multiply, the number of moles divided by the volume. So that's going to be my previous answer. And I'm going to divide that all by the volume of my hydrochloric acid, which is 0.0200. And then I can put that in my calculator. And you saw the answer just pop up because I just did it previously. Times 0.0237 equals, and divide that by 0.02, and we get 0.711. So that's going to be 0.711 moles per litre HCl. So guys, that's how you complete a stoichiometric practice problem. So check out the link in the video description and practice a few more, and good luck.